Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. How are you guys doing? Waalaikumsalam Mai. Waalaikumsalam Aisyah. Good morning Pei Chong. Waalaikumsalam Haris. Good morning Amira. Waalaikumsalam Umi. Okay, so I hope you are good. Okay, and good morning Navin. Okay, today we'll be discussing and also we're going to wrap up topic 10. Okay, so which is the last topic of this semester. Okay, so I hope you guys are ready and I also hope that you have covered, okay, and you have finished watching all the lecture videos on YouTube, okay. So the link I've given you last Saturday. Okay, so and I need to remind so there are few of you who still have not submitted the lecture notes for topic 10. So for those who have not done so please make sure you submit because I just need to check whether you really watch the videos or not. Okay, and in fact some of you have already asked me some questions on topic 10, so which shows that you have actually covered the videos. Okay, and so now let's discuss some of the past year questions on topic 10. But before that, so let's see the summary of this topic. Okay, so you can see here topic 10. So it's special probability distributions. Okay, so why is it called special probability distributions? Because we are dealing with probabilities, for both discrete and continuous random variables. Okay, and for discrete random variable, we will have two distributions to model the random variable. Okay, so one is binomial distribution and the second one is Poisson distribution. Okay, so this one, we pronounce this as Poisson distribution, not as poison. Poison is something that you consume that will cause you death. Okay, so that is poison. Now this is Poisson distribution. So this is actually a French word. So if you want to pronounce this French way, it's actually Poisson distribution. Okay, so this can be used to model discrete random variable as well. And for continuous random variable, we only have one distribution, which is normal distribution. Okay, so these three distributions will be discussed in our syllabus. Okay, so first, what is binomial distribution? So binomial distribution is used to model discrete, right? And we have to make sure that these conditions being satisfied. So among the conditions are, so in order to use binomial distribution, you have to make sure that finite number and trials are carried out. So we know the number exactly, the number of trials carried out. And then for the second condition, the trials should be independent, which means the occurrence of the following event will not be affected by the occurrence of previous event. Okay, so for example, probability of getting a boy. For example, if a woman gives birth to a baby, so let's say probability of getting a boy is 0.6 and probability a girl is 0.4. So this is the event of getting a girl, let's say. So this is for the first baby. Okay, so what does it mean by independent? So independent means the event of getting second baby does not depend on the event of getting first baby, which means the probability of getting a boy is still 0.6 and the girl is still 0.4. So again, the trials must be independent, which means here the event of getting the second child does not depend on the event of getting first child. Okay, so that is what it meant by independent. So the probabilities must be the same. Okay, and then the outcome of each trial is either success or failure. So we should only have two outcomes. It's either success or failure. That's it. You cannot have in between. Like this one, it's either boy or girl only. You cannot have in between. Or for example, if we talk about match between two teams, so it's either team A wins the match or team B wins the match. Okay, so we cannot have one more outcome to be draw. Okay, it is not possible because for this binomial distribution to be used, so it's either it's either success or failure only. Okay, so in this case we cannot have the outcome of draw, so it has to be either A win the match or team B win the match. That's it. Okay, and then the fourth condition is that probability of success is the same for each trial. So this is to support the second condition just now. So when the trials are independent, so we can say that the probability of success is the same for each trial. Okay, because again, the occurrence of the following event is not depending on the occurrence of the event that has already happened. Okay, so this is binomial distribution. Okay, and if you have a look at the table of binomial, okay, so the maximum probability of success is 0.5. So for some cases, you might have the event to be where the probability of success is greater than 0.5. So for that case, so table cannot be used. So in order to make sure that we can use the table, so these are the formula that we're going to apply. So in this case, we are going to use the complement event. So if X is the event, so we are going to use complement event to help us to find the probability. So we will see the example later by solving past year question. And then what about Poisson distribution? So this Poisson distribution can also be used to model discrete random variable. So where this is the formula of getting probability. And in this case, X can be up to infinity. It doesn't have any limit. And we do have conditions. There are 3 conditions for Poisson model to be used. So the first condition is that the events occur one at a time and at random. So we cannot have a few events to occur at the same time. So it has to occur one at a time. And then events occur in a given interval of time or space. So for example, you have number of students in a class. So we are talking about discrete, right? So for example, number of students in a class. So this is what we call as space, where in a class. So let's say it can be modeled using Poisson distribution with lambda. And for example, if I change the space, so I change this to another variable y. So y is number of students in 2 classes, for example. So I change the space now, I double the space. So in 2 classes. So we can say that here the lambda is going to be double. So it can be modeled using Poisson distribution with 2 lambda. Why? Because the space has been multiplied. So first in one class. So if you double the space, so the lambda also be doubled, right? So then where the third condition is that lambda or the mean is known and finite. So we know, and it's given in the question. Right. So then the next, we move on to continuous random variable. We use normal distribution to model continuous random variable. But for normal distribution, we can have different values of mean and variance. So this is the mean. It is represented by the mu symbol, and the variance is sigma squared. All right. So because there can be different, because we are talking about continuous. So continuous, it can be within intervals, right? For example, weight of students, weight of grains, length of time, so on and so forth. So any random variable can be measured within intervals, so we can use normal distribution. But because the mean and variance can be broad, so in order to read the table, so we standardize. So we need to standardize the random variable so that it will become standard normal distribution. So once the process of standardization, so then we can only read the standard normal distribution table. So that's the purpose of standardization, so that we can have only one type of table for normal distribution, which is standard normal table. Then when it comes to 10.4, distribution approximation is where we try to transform the discrete to become continuous random variable. So the process is called as continuity correction. So you see, binomial distribution is originally for discrete. So when we do the continuity correction, so the random variable will be transformed to continuous random variable. And but we cannot read the normal table, right? We only have standard normal table. So what do we need to do? So we need to do standardization step. So the purpose of having this continuity correction is when we have n to be too big. Okay, because you can see in binomial table, okay, the n is restricted until 50 only. Okay, so this is in NP is 0.5. So this is the maximum value of n and maximum probability of success from binomial table. So we have this limitation. So this is the maximum measures, okay, in binomial table. So we have this kind of limitation in our binomial. Okay, so you can see that as n gets larger, all right, and where the NP, okay, gets greater than 5, so we cannot use the binomial table, okay, to read or to get the probability. So in this case, okay, distribution approximation will be performed. So these are the conditions for normal approximation to be done. Okay, the first condition is NP must be greater equal 5, and the probability of success must be between, okay, from 0.1 and 0.9. And this is actually the continuity correction formula. So this is continuity correction formula. Continuity correction, or okay, I will use CC as the short form. Continuity correction. So this is the formula of continuity correction, but you don't really have to memorize this. I'm going to show you the easier way to do continuity correction without memorizing this formula. Okay, so now let's see example. So in this today we will be discussing some of the past year questions, okay, which is not in the tutorial book. Okay, so okay, let's begin with 14-15. Okay, so now how do we tackle these questions? Okay, so let's have a read. Okay, a survey found that 32% of teenage consumers earn their spending money from working part-time. Okay, so this is the idea. So 32% of teenage consumers earn their spending money from working part-time. Okay, so this we can say that we are talking about number of teenage consumers, right? Okay, so teenage consumers earn money from working part-time. Okay, so in this case, I'm going to declare the random variable so as number of teenage consumers. Okay, so if 5 teenagers are selected at random, so now we can say that this 5 is basically the n. Okay, while 32% can be transformed into probability, which is 0.32, and that's going to be the probability of success. Okay, so if you're talking about number of teenage consumers earn money from working part-time, okay, so this is the event. All right, so now the question says find the probability that at least 2 of them. So when we are talking about at least 2 of them are working part-time, so at least 2 means it has to be greater equal to. Okay, so if you talk about the probability, so we have maximum number of teenagers, 5, right? Okay, so we have maximum number of teenagers, 5. So the question says find at least 2 of them means is greater equal to. So you can actually find the probability, okay, of x equals 2, x equals 3, x equals 4, x equals 5. So in this case, I just need to remind you that table cannot be used. Why table cannot be used? Because, okay, in the binomial table, you cannot find the probability of success to be 0.32. Okay, so again, let's have a look at the binomial table. Okay, so we don't have any probability of success to be 0.32. We only have 0.3 and 0.35. So you cannot round off the probability of success 0.32 to become 0.3 because the readings is not going to be accurate. Okay, so that is one thing. So which means in this case, we cannot apply the table. So which means we need to use the formula. Which formula that we need to apply? So, okay, we go back to the binomial distribution just now. Okay, so if table cannot be used, so which means we need to use the formula. So in this case, the formula that we're going to apply is this. Okay, and you don't really have to worry in exam, this formula is going to be given, it's going to be provided to you. Okay, so now let's have a look at this. So, okay, you can find the probability of x greater equal to by finding probability of x equals 2, 3, 4, and 5. But this is going to be a bit long. Why? Because you need to apply the formula and apply it 4 times, First year, second year, third year, fourth year. Or, okay, alternatively, what you can do is you just do 1 minus. Okay, so rather than finding probability of x equals 2, 3, 4, and 5, what you can do is you can just do 1 minus probability of x equals 0 minus with also probability of x equals 1. Because, okay, again, as I told you just now, binomial is used for discrete random variable, right? So because n is 5 in this case, so 0, 1, 2, 3, 4, and 5. So basically, we want these dots. We want 2, 3, 4, and 5. So the dots that we don't want, okay, so these two dots that we don't want. Okay, so what can you do is you just get the cumulative. We know that the probabilities of all these dots is equal to 1, right? Okay, because we discussed the basic law of probability saying that sum of probabilities is 1. Okay, so what we can do is, okay, the total is 1, then we just minus with these two dots that we don't want. So that's why the formula is 1 minus probability of x equals 0 and probability of x equal 1. Okay, because we don't want these two dots. We want only these 4 dots. Okay, so then we substitute into the formula 5C0 times 0.32 power 0 and the probability of failure 0.68 power 5, and then minus also this one is to get probability of x equals 1. Yeah? So 5C1 times 0.32 power 1 times 0.68 power 4. So we get the answer to be 0.5125. Okay, so we have 5 marks here. So again, please make sure you solve this question within 5 minutes only. Okay, so now let's proceed with the next one. Okay, so just now we have binomial. And next, okay, so let's have a look at this question. Number of accidents at a particular location of a highway occurs at the rate of 1.6 per week. So now, okay, the idea is we have number of accidents. So when it comes to number of accidents, so it's either binomial or binomial or Poisson, right? We can use either one of these distribution to model. But how do we decide which one to use? Okay, so in this case, because we are given the time. Okay, because we discussed just now, right, for Poisson distribution. Okay, so for Poisson distribution, the idea is, okay, we have this. Okay, for Poisson distribution, the events occur in a given interval of time or space. So in this case, we are given the interval of time, yeah, per week. Okay, the idea is number of accidents per week. Okay, so in this case, we know that we are going to use the Poisson distribution to model this random variable. So the rate is 1.6. So we can say that this is actually the lambda. Okay, so we declare first the event. So X is basically number of accidents per week. Okay, and then because the lambda is given as 1.6, so okay, it can be modeled using Poisson distribution with lambda 1.6. Okay, then the question says find the probability there will be 2 accidents in a week. So now, okay, because again our random variable is still talking about accidents per week, right? So in a week, so there will be 2 accidents, which means we need to find probability of x equals 2. So in order to answer this question, so okay, you can use the formula. So probability of x equals 2 is basically e power of negative 1.6, okay, multiplied by 1.6 power of 2 divided by 2 factorial. So the formula can be obtained from this. Okay, so this is the formula that we may use. Okay, so probability x equals x is e to the power of negative lambda times lambda power of x divided by x factorial. Okay, and this formula will be given in exam, so you don't really have to worry. Okay, so this is the answer, 0.2584. So the question is, can we apply table? Let's say if you want to use Poisson table, can we apply the table? Okay, so now let's have a look at the lambda. Okay, do we have lambda 1.6? Okay, so if you do have lambda 1.6, alright, so this is where the lambda is 1.6. Okay, so now you want this, okay, so you want the probability of x equals 2, right? So the probability of x equals 2. So if you want to use the table, okay, so or you can use table. Okay, use table. So we can find probability of x equals 2 by having probability of x greater equal to minus with probability of x greater equal 3. Why? Because again, Poisson is also used to model discrete, right? So now the idea is we want this dot. Okay, but because the table, okay, can only read from one particular value to the right, right? So what do? So we just get 2 to the right. So it can be up to infinity, yeah? So this can be infinite dots here. Okay, it can be x greater equal 2 and then minus with this. We don't want this. 3 to the right. Okay, so how many? So if you subtract, okay, so this one will be gone. So if you subtract this, so this one will be gone. So you only left with this dot. Okay, so how to get probability x equals 2? If you want to use table, it's probability of x greater equal 2 minus probability of x greater equal 3. So if you have a look at the Poisson table, so when R is 2, so this is 4751 and 0.2166, yeah, 4751. Okay, 0.4751 minus 0.2166. Okay. Okay, so if you use the calculator, so you will see that 0.4751 minus 0.2166 will be 0.2585. So you will see that, okay, the answers are more or less the same, okay. There is just a bit difference because actually the values in the table are approximations, because we round off the values correct to 4 decimal places, right? So there will be plus minus, there will be a slight difference between the answers. Okay, but again, if either one you use, okay, you will still get, okay, full marks, so you don't really have to worry. Yeah, so you can see the application. So it's either you use table or you may use the formula to get the answer. Okay, now let's continue with the next question. There are more than 10 accidents in a 5 weeks period. So now you can see that the interval, okay, the interval of time has been expanded. Okay, so you can see clearly, originally it's in a week. So now the interval of time has been expanded to 5 weeks period. So originally the lambda is 1.6. So you just multiply by 5. Okay, so now the lambda is going to be 8. All right, so the lambda is 8. So you may, okay, you may see that, okay, you may notice that at first I use the random variable x. So now I change it to y because now it's still, okay, it's still about number of accidents, but you can see that the interval of time is expanded to 5. So X is about number of accidents per week. So now Y is about number of accidents in 5 weeks. Okay, so you can use this Y letter to represent the new random variable. So it can be modeled also using Poisson distribution. It's just that the lambda has been expanded 5 times. Yeah? So from 1.6, then you just multiply by 5. So the lambda is now 8. Okay, so now the question says there are more than 10. So more than 10 means y greater than 10. But we cannot find this value from the table because, okay, in order to find or use Poisson table, okay, so you can only use Poisson table when you have probability of x greater equal r. Because why? Poisson table is for discrete, right? And we discussed in topic 9, for discrete random variable, the equal sign matters. So when it comes to discrete random variable, the equal sign really matters. So now we don't have equal sign, that means we cannot read table yet. But we know that when y greater than 10 means, okay, it's going to be y greater equal 11. And then from there, you can read the table. Okay, so now, okay, please take note that our lambda is now 8. Okay, so how to read the table? So you just go to Poisson table. Okay, so find lambda 8. Yeah, so where is lambda 8? So you scroll, okay, or you flip through your book, okay, your statistical table book, until you find lambda equals 8. So now lambda equals 8. Now the R is 11, right? Okay, so now you see the probability is 0.1841. Okay, so 0.1841. So this is the answer. Okay, so as soon as you read the table and give the value, you will, okay, get 3 marks. So this topic is quite interesting. So because we don't require too much or long working solutions. Okay, it's just about a skill, okay, to read the table. So you have to know how to read the table in order to provide correct answer. Okay, now let's have a look at the next question. Okay, an egg is classified as grade A if it weighs at least 100 grams. Suppose X lay at particular farm has the probability of 0.4 being classified as grade A eggs. Okay, so now we can see that the probability of success. So the probability of success of getting grade AX is 0.4. So now if 15 eggs are selected, so this is actually the number of eggs or the n. Okay, so what do we do? So I'm going to declare the random variable. So now I declare the x as number of grade A eggs. So out of 15, so it can be modeled using binomial distribution where the n is 15 and probability of success is 0.4. So number of grade A eggs, and it can be used, okay, it can be used, binomial distribution can be used to model. And then, okay, let's solve the question. Calculate the probability that more than 20% of them are not grade A eggs. So now, originally we are talking about number of grade A eggs, right? But now the question says find the probability that more than 20% are not grade A. So you don't really have to worry. Okay, so from X just now, we just get the complement event of this. Okay, because if we have grade A eggs, X to be grade A eggs, so we know for sure that X prime is going to be not grade A eggs. Okay, and if X is binomially distributed with probability of success 0.4, which means the probability of failure is going to be 0.6. So it's going to be the probability of success for the X prime. Okay, so again, probability of failure for X is going to be probability of success for X prime because they are simply complement events, right? Okay, and now 20% of them. So 20% of them, so them here refers to the 15 eggs, yeah? So 20% of 15, so you can find that 20% of 15 is basically 3. So now the question says find the probability that more than 3 eggs are not grade A. So if we declare the X prime to be not grade A, so the question says more than 3 of them are not grade A. So this is how we write it down. More of them, okay, greater than 3 are not grade A. But we do have a problem here. Because why? You can see that the probability of success is 0.6. So in this case, okay, if you want to find probability of X prime to be greater equal 4, so this cannot be found anywhere in the table. Okay, so let me write it. It can't be found from table. Why is that? Because the probability of success for X prime is 0.6 and 0.6 cannot be obtained anywhere in the binomial table. Okay, I repeat. The 0.6 cannot be obtained anywhere in the binomial table because if you have a look at the binomial table, okay, the maximum probability of success is only 0.5. So if you flip through the statistical book, you can see only 0.5 as the maximum value of the probability of success. So that is why whenever you have probability of success to be more than 0.5, we are going to use the formula. But then, okay, if you don't really remember the formula, it's not a big deal. Why? Okay, how can we do this? Okay, now we want more equal, yeah? So which means here there are more equal, okay, greater equal 4 not grade A. So we are going to use this table. Okay, first thing first, you just construct this table. Okay, now we want more equal 4, yeah, greater equal 4 not grade A. Yeah? So X prime here refers to not grade A. Okay, not grade A. And X here represent grade AX. So now we want X prime to be greater equal 4. Greater equal 4 means from 4 to the right? So it will be 4, 5, 6, 7, 8 and until 15. Okay, because we have maximum of 15 X in this case. So it's going to be 4, 5, 6, 7 and so on. So you can see that the number of grade not grade AX are going to increase. Yeah. So 4, 5, 6 and 7 and so on. And now, okay, let's have a look at the complement event. The complement event is grade A. Okay, so if there are 4 not grade AX, so out of 15, there must be 11 grade AX. If there are 5 not grade A, so we know that there are 10 grade AX. And if we have 6 X which are not grade A. So we know that there are 9 grade A X. Okay, because we know the total must be 15, right? So 15. So what you need to do, you just need to make sure that the sum is 15. Okay, so now you can see that as X prime gets larger, the X here will get smaller. So this is basically X less equal 11. So you can see that, okay, from this formula, so basically, originally, this is the probability that we need to find. Okay, X prime greater equal 4. Okay, but because we cannot read the table, since the probability of success is 0.6, so now we are going to use the complement event. So in this case, the complement event is X. Okay, so as X prime greater equal 4, so we can see that X is less equal 11. Okay, so you can see that without using formula, we can actually obtain the probability. So by constructing this table. So again, okay, so this is actually the formula that we apply. So basically, this is the formula that we apply here. So you can see that, okay, originally we want this. Okay, X prime greater equal 4. So this is X less equal 15 minus 4, which is 11. So basically, this is the probability or the formula that we apply. But again, if you don't, okay, if it happens to be that you don't remember this formula in exam, you don't really have to worry. You can just construct the table here. You list down the values. So as we want the X prime to be greater equal 4, so you can see that the X prime will get larger. And okay, you just take the complement event of it. Okay, so you can see that as X prime gets larger, the X here will get smaller. So basically, X will be less equal 11. But still, we cannot read the table because the table only gives us probability of X greater equal R. Yeah, so this is from binomial table. So, okay, we want 11 to the left. So we don't want 12 to the right. Okay, because we are talking about discrete, right? So, okay, it's from 0, 1, 2, 3 until 15, yeah? So if you want to list down, it will be until 15 lah. Okay, dot, 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 dot. Okay, so 11, 12, 13, 14, 15. Okay. So 13, 14, 15. So we want this X less equal 11. So it will be 11 to the left. But this cannot be found from the table because the table only gives us probability X greater equal R, right? So we want this, but we don't want this, 12 to the right. Okay, we don't want this, 12 to the right. So that is why it's going to be 1 minus probability of X greater equal 12. And okay, if you read the table, so it's going to be 0.0019. How can we read the table? Now let's see, the n is 15, probability of success is 0.4. So if you refer binomial table, n is 15. So first you just find the n. So n is 15 is here, and probability of success is 0.4. So 0.4 is here, in this column, and the r here is 12, right? So the 12 is here. Okay, so if you read the table, so you can continue until this. So it's 0.0019. Okay, so 0.0019. So you just bring the value here and you perform the subtraction. So this is the answer that we are looking for. Okay, so again, guys, if you have any question throughout the discussion, so you can just ask in the live chat now. Okay, now next, a retailer bought 500 eggs from the farm. Okay, so now the n gets very, very big. Okay, originally we are dealing with it discrete and a variable with n15. So now n gets larger, 500. Okay, so which means in this case we cannot use the binomial table anymore. Okay, and the question says approximate the percentage that the retailer would have bought from 220 to 230. So in this case, we know that we are going to use continuity correction. Okay, so from discrete, it's going to be continuous. Okay, why? Because n gets larger in this case. And yeah, because the NP will be greater equal 5, yeah? So, okay, let's see here. Okay, now we still have number of grade A, yeah? So we are dealing with number of grade A, X. Okay, but now, okay, the n gets larger, 500, yeah? So originally it's binomial distribution, so we can use binomial distribution to model. Okay, but then yeah, we cannot use the table, and the number is so big, so we need to approximate this. Okay, so this one is discrete, so this is discrete. So we from binomial, so we are going to transform to normal lah. So this is what we call as, okay, transformation. Yeah, okay, so we do approximation with the variance. Okay, so how to find the variance? Okay, or the mean is NP. So this is the mean. Okay, and the variance is NPQ. Okay, so how to get the NP? So NP can be obtained from the binomial just now. So this is binomial NP. Okay, so and when it became normal distribution, so this is going to be NP and PQ. Okay, where the mean and the variance of the normal distribution. Okay, so we get the NP and then we get the NPQ, so we bring it down. Okay, so now the discrete has become continuous. Yeah, so here from discrete it has become continuous. Okay, so from discrete and variable it has now become continuous. So now coming to the question. So the question says find the probability, find the percentage that the retailer would have bought from. So the keyword here is from. Yeah? So from means 220 and 230 are inclusive. So inclusive, because the word here from. So that's okay. So here you may notice that I put the equal sign here, because the keyword here is from 220 to 230 grade AX. Okay, so before we do that, okay, before we find the percentage, so okay, now you see this is discrete and a variable. Okay, so what do we need to do? We need to do continuity correction first. We need to perform continuity correction so that it will become continuous random variable. Okay, so how to do continuity correction? Okay, very easy. What do you need to do? You don't really have to memorize the formula just now. Okay, so basically this is the formula that we're going to apply. So this is the formula of continuity correction. Okay, so this is the formula that we're going to apply. Okay, so these are all the formula of continuity correction. Okay, but you don't really have to memorize this stuff. Okay, so what to do? Okay, you just draw a bar. So basically, okay, this is the bar. So I redraw this. Okay, we want from 200. Okay, why do we draw a bar? Because previously it is binomial distribution whereby it's discrete and non-variable. Okay, so this one 220, 230. But now since, okay, we change it, we transform it to continuous. So we just draw a box here. Okay, so now it will become continuous. So, okay, first we want it to be in between, right? So in between, we shade this region. Okay, so now, and because of this equal sign, okay, we are going to shade this box for 220. So which means in this case, so it will begin from 219.5. Okay, and then because of this equal sign as well, so we are going to shade this box of 230. So it will end at 230.5. Okay, because when we talk about approximation, let's have a look at the summary. Originally it is discrete like this one. It consists of these boxes. So we transform it to normal. We transform it to normal distribution. By having this kind of curve shape. So it's basically getting the midpoint of each of the bars here. So the midpoint by collecting or by joining all the midpoints of the bars. So we can get a normal distribution. So so that's why we draw this bar. And we know the midpoint of this bar is 220. But because there is equal sign here, so we shade the 220 bar. And you can see that this is going to be 219.5. And because this is also equal sign, so which means we shade the bar of 230 as well. So it will be 230.5 here. Okay, so performing continuity correction, so you will notice that from 220, so it has become 219.5, and from this 230 it has become 230.5. So this is what we call as continuity correction. Okay, but we cannot read the table, okay, because we don't have any normal table. We only have standard normal table, right? So what do? We need to standardize this, okay? So the process of standardization is going to be, okay, is going to be, so in order to get standard normal, okay, in order to get standard normal score, so the formula is x minus with mu divided by standard deviation, okay? So this is the Z score, yeah? So in order to obtain the Z score, so you just get this value, you subtract with the mean, and you divide by the standard deviation. So from you will notice that from X here, it will become Z. Okay, why? Because from normal, we transform it to become standard normal so that we can read the table. So this one also, we do the same. So the 230.5, we minus with the mean, we divide by the standard deviation. So we will get this Z score. So this is the Z score. Okay, so if you draw the bell-shaped curve, 1.78 is located here. Okay, because this is 0, right? The mean of standard normal is always 0. So 1.78 is located here and 2.78 is also located here. So how to get this region? Okay, because yeah, for standard normal, you can only read this, x greater than r. And yeah, because for this normal distribution, we are dealing with continuous random variable, right? So in this case, the equal sign does not really matter. Yeah? So the reading is just the same. Whether you have equal or not, okay, it's just the same. So now we want this shaded region. So how do we get this shaded region? So basically by having probability of z greater than 1.78. Okay, so 1.78 to the right minus with 2.78 to the right. Okay, so if you get this and then you minus with this, so you will get exactly the shaded region here. Okay, so then how to read the table? Okay, standard normal table. So this is 1.78, right? So we just find standard normal table, 1.78. Okay, so 1.7 is here and 0.08 is here. So 1.78 is basically this value. And then 2.78, so 2.7, so 0.08 is here. So this is 2.78. So you just get the two values, you bring it here. Okay, so this is the reading from the table, and then you just press calculator. So this is the probability, but this is not the final answer yet because the question asks for percentage. So in order to find the percentage, you just divide by 1. Why 1? Because sum of probabilities is 1. Okay, total of probabilities is 1. So the probability here divided by 1 multiplied by 100. So this is the percentage that we are looking for. Okay, so again, this is the answer of percentage of grade AX, percentage that the retailer would have bought from 220 to 230 grade AX. Okay. Okay, now let's have a look at the next question. Okay, if the probability not more than M. Okay, so let's have it again, not more than M. So how to transform this statement into mathematical representation? So not more than M, tak boleh lebih M. So which means it, okay, tak boleh lebih M maksudnya M dan ke bawah. Okay, not more than M, ya, tak boleh lebih M. So it can be M than M and less than M, which means, okay, so not more than M is basically X less equal M. So now the questions, okay, the question gives us this information. Okay, the probability of X less equal M is equal to 0.9956. Okay, so determine the value of M. So now how do we do this? Okay, now again we are dealing with this discrete. So please take note, in this case M is discrete. Okay, so now what do? We are going to perform continuity correction, so then it will become continuous. Okay, because from binomial just now we transform it to normal, right? Okay, so how do we do this? Okay, again you just draw the bar. So okay, let me redraw the bar. So this is the bar of M. So the midpoint of the bar is basically M. Okay, so this is the midpoint of the bar. Okay, so now less than. So we want it to be less than, so we just shade this region. Less than, it has to be on the left of M. Okay, now because of this equal sign, let's have a look at this very closely. So because of this equal sign, which means the bar of M will be shaded as well. So I repeat, because of the equal sign here, the bar of M will be shaded as well. So now it will stop at this. So what is this value? Because it's located on the right of M, so this would be M plus 0.5. So by by performing continuity correction, so you can see that from M here, it has become M plus 0.5. From discrete, it has become continuous by performing continuity correction. Okay, now after we do continuity correction, what's next? Okay, we still cannot read the table because we don't have normal table. We only have standard normal table. So what do you need to do? We need to standardize this X by changing it to Z score. Okay, so the process here is called standardization. Standardization, because again, we don't have normal table. We only have standard normal table. Okay, so you can see here, this is not normal table. It's supposed to be standard normal table. Standard normal table. So as you can see here, standard normal distribution table. Okay. Standard normal distribution table. Okay. So now, okay, we perform the standardization. So it's M plus 0.5 minus the mean. Okay, minus the mean divided by the standard deviation. Okay, is equal to 0.9956. Okay, so then we simplify it, so it will be M minus 199.5 divided by standard deviation. But okay, we cannot read the table because this is Z less than. Okay, so how to read the standard normal table? Okay, if I draw the bell-shaped curve, the area here gets too big, right? Okay, it's if standard normal, the mean is always 0, right? So we know that this area is 0.5, while this area is also 0.5. So now, when we have this reading 0.9956, so the reading is quite big, right? It's almost 1. So we know that, okay, if this is less than, so we know that, okay, the score is going to be here. This is where the score is M minus 199.5 divided by set of 120. Less than means this is the area. This is where the 0.9956 is located. But because we cannot read the table, okay, because less than sign. So what do we need to do? We take the complement or the opposite area, which means we are going to take this region. So we change this less than sign to greater than, so it will become 0.0044. It's 1 minus 0.9956, so it will be 0.0044. So then, okay, how can we read the table? So you just go to the standard normal table. We try to find where the 0.0044 is located. So if you have a look here, this is where the 0.0044 is located. And you can see that the Z score is 2.62. So 2.62. Okay. So coming back to this, so from table, probability of Z greater than 2.62 is 0.0044. So we just compare the Z score here. So you just equate this, M minus 199.5 divided by 120 is 2.62. So M is equal to 228.2. But now because we are dealing with discrete and a variable, it's about number of x, right? So we round it off, so it will be 228 x, okay? So this is how to solve continuity correction problem. Okay, so there are 4 marks here. So please make sure you just solve this question within 4 minutes only. Okay, now next, 15, 16. In the Google Classroom, so you don't really have to worry if you if you didn't manage to copy down the solution. Okay, so now let's have it. The length of newborn babies is normally distributed. So now we are talking about length of newborn babies with mean 52 and standard deviation 2.5. So the way to write this is going to be 2.5 squared. Yeah. Okay, then a baby's length is considered normal if it is between 46 and 56. So we get the probability of 46 to 56. Okay. So because this is normal, and we need to standardize it so that we can read the standard normal. Okay, and in this case, we don't have to do continuity correction because it's already in normal. So we are dealing with continuous random variable. So this is continuous random variable. So we don't have to do continuity correction because this is already normal. So, okay, so we just do standardization. So the process here is called standardization so that we can read the standard normal table. Okay, so you just get the Z score, and this is the region that we are looking for. So it's 1 minus this region and this region. Then you just, okay, rotate this region is basically this. Okay, probability of Z less than negative 2.4 is the same as probability of Z greater than 2.4. And then you just read the value from the table. Okay, and this is the probability of, okay, normal length babies. Okay, now the question says, from a list of 100 birth records selected, how many babies are expected to have normal length? Okay, now we are talking about different random variables. So in this case, we are talking about number of babies having normal length. Okay, so we have 100 birth records, which means we have 100 babies. So out of 100 babies here, and the probability of success, okay, or probability of getting normal length is 0.937. We just bring down the value here. Okay, so we have this value and we just bring it down. Okay, and now the question says how many babies are expected. So the word expected is basically expectation. Okay, so when it comes to expectation, so we are looking for NP. Okay, so what do? We just multiply the N here. So this is the N, and this is the probability of success. Okay, so how many babies are expected to have normal length? So out of 100, we just multiply by the probability of success. And yeah, because we are talking about number of babies, so we cannot have decimal, so we round it off. So we have 94 babies. Yeah, so there are 94 babies expected to have normal length. Okay, and number 3 is about Poisson distribution. Okay, we have about the number of demands. Sorry, we have number of demands. Okay, per day. Okay, because it's stated here per day, right? Okay, and the lambda is 3. So, okay, find the probability that the company cannot meet the demand because there are only 7 cars available. So, probability that the company cannot meet the demand, which means, okay, the demand has to be more than the cars available. So which means, okay, when the demand is greater than 7, so which means the company cannot meet the demand already. Why? Because there are only 7 cars available. So if the number of demand is greater than the number of cars available, so the company cannot meet the demand. Okay, so which means here X greater than 7, but we cannot read the table because there's no equal sign, because Poisson is about, okay, this is for discrete random variable, right? So Poisson is for discrete random variable. So again, the equal sign really matters. Okay, so in order to read Poisson table, you must have probability of X greater equal. So if you don't have equal sign here, so you just get moved to the next value. So it's X greater equal 8. So you read the Poisson table, you will get this probability. Okay, now the number, okay, so now the time duration is expanded. So next question, less than 5 cars rented in a period of 3 days. So originally we have per day, 1 day. So now we multiply by 3. So it has become 3 days. So we know that the lambda here is going to be expanded. So 3 times 3 will be 9. So now we have new value of lambda. Lambda is 9. So now we want the probability less than 5. So less than 5 means y less than 5. But again, we cannot read the table. So it's 1 minus probability y greater equal 5. And you just read table, and this is going to be the answer. Okay. Alright, guys. Okay, I'm gonna share this in the Google Classroom. So I hope that you can just go through the solutions. If there's any part that you don't understand, you need further explanation. So we'll discuss in the class, okay, in tutorial class. Okay, so as well as this passing question 16, 17. Okay, so I hope that you try to understand this topic, yeah, well, because okay, we had discussed the JPU, right? Okay, this topic 10 carries about 1/4 of the total marks. Okay, so I hope you'll be able to understand this topic very well, so that you'll be able to answer the questions correctly, and eventually you'll be getting A for maths. Okay guys, so it's now 4 minutes to 11 o'clock, so I think that's all for today. Okay, again, any problem you may just ask me, yeah. Okay, so I stop here guys, so thank you for your attention and thank you for your presence. So I end the lecture with Assalamualaikum warahmatullahi wabarakatuh, and have a nice day everyone. Bye bye.